So what's going on, guys? DIY Dan here, and this is another mechanical video. In this video, I had the alternator go bad on this 2011 Grand Marquis with a 4.6 liter V8 engine. Now this engine is in a lot of Ford vehicles around this same year, so it might help you out even if you don't have a Grand Marquis. I'm going to go over how to do some preliminary checks to make sure your alternator is bad, and then since mine was bad in my mom's car, I'm going to show you how to replace it. So this does have a smart charge alternator, basically to improve emissions and fuel economy. So there is a couple things that, as far as the wiring goes, that we can't really check unless you have a PICOSCOPE. But I will show you some other preliminary checks you can do to help narrow it down. Here is a chapter index of what takes place in this video and what time it happens. So if you're only looking for specific information, you can bypass what you don't need to see, so I don't waste your time. And let's get to it. So there is a couple preliminary checks we can do with a basic multimeter to help see whether we do have a bad alternator. So the first thing we need to do is get the car where it will start on its own. So we might need to put a battery charger on the battery and get it charged up, or use a set of jumper cables to get the battery charged up. However, we want to use the jumper cables to charge up the battery so the car will start on its own, not start the vehicle with the jumper cables. The reason for that is we're trying to get a baseline of the battery voltage before and after the vehicle is started, so we can judge whether or not the alternator is working. If you've got the jumper cables on it, you're going to read a higher voltage than what the battery actually has, and that might give you false information after starting the vehicle whether it's actually working. So we've got the vehicle charged up. So what we're going to do is take our multimeter and put it on DC volts. We're going to put the black lead on the negative and the red lead, or whatever lead, on the positive, and see what our baseline is. Let's say we've got 12.2 volts. Then we want to start the vehicle, and after we start the vehicle, we want to see what our voltage is doing at the battery. So if we were reading 12.2 volts before we started it, and once the vehicle is started, we're still reading 12.2 volts or less, say we're dropping into the 10s or the 11s, then obviously our alternator is not charging. Now, when you start it, if it climbs up to 13 to 14 volts, our alternator is charging and we might have a different problem with your vehicle. For the purposes of this video, we're going to say that we were at 12.2 and now we're dropping below that voltage, say we're getting down to 10 or 11. Then what we want to do is leave the black lead on the negative and go over to the main battery lead on the alternator. And we want to make sure whatever the battery is reading, if it's 11 volts, we want to make sure we're reading 11 volts to this point on the alternator. If we're reading 13 volts at the alternator and only 11 at the battery, it could be something as simple as a loose connection or a bad wire between the alternator and the battery. There's also a fusible link that can burn out if that wire ends up shorting out to ground. We also want to see the same voltage that we have here, also to pin number 3 on the alternator. Now we can use a little needle to poke into that pigtail while it's running and make sure, once again, that the voltage here should be the same as here and should be the same as here. And it doesn't matter what that voltage is. If we have a difference in voltage, again, we need to check our connections. This is where it gets a little tricky. Pins 1 and 2 at this connector are going directly to the PCM for this smart alternator. We have a signal going out from the alternator, which is the sense wire. That PCM takes the sense from the alternator and delivers a command to pin number 2. Now these are pulse width signals, so they are kind of basically useless to do anything with our multimeter. However, Ford put a default in that if you unplug this pigtail, this alternator will go to a fixed voltage of like 13.5 volts. So that is a basic check for a Ford Smart alternator, is just unplug this pigtail and see if you start getting your 13 volts or 13 to 14 volts at the battery. So one of the quickest things to do to verify whether your alternator is putting out voltage is just disconnect that pigtail off of the alternator and see if you get that 13.5 volts or so going to the battery. If you do, you might just have a bad wire going to and from the PCM. If you unplug that harness and you're still not getting that 13 volts coming out of the alternator, then you definitely do have a bad alternator. Now, if you do unplug that 3-wire pigtail out of the alternator and you are getting that 13.5 volts to the battery, That doesn't necessarily mean there's not another component like the regulator that is going bad in the alternator. It just means that the generator part of the alternator is still working. So now I'm going to go over some of those preliminary checks that we just went over on the actual vehicle. So the first thing I did was pop the hood and remove the cover over the top of the engine. Using a 1/4-inch ratchet with an extension, I broke that loose, and then that cover slides forward a little bit and up and out of the way. Right here, I'm using my multimeter to test my voltage at the battery, so I have a reference of what I need at the main power supply to the alternator. So right here, I pulled back the rubber boot that's on the main charge wire going to the alternator. I've got my multimeter on DC volts, and I've got the red wire going to that charge wire with the black wire going to the negative on the battery. And I'm getting 11.07 volts, which is the same that I had on the battery, telling me that this cable was fine. However, if that voltage is not reading the same or within a decimal point or two, you could have a bad connection on that cable or a bad cable itself. So when I actually first started checking the wiring on this alternator, I was unaware that it was a smart charge. So I was actually looking for a key on power, a ground, and then a constant power on this pigtail. So right here, I've got my multimeter on DC volts, and I've got the key in the on position, and I'm checking those voltages. Notice I only had 8.5 volts at the battery. Now with that key in the on position, I actually do have some type of a reference voltage at pin number 1 on that pigtail. And that does tell us something. We do have some type of a reference voltage coming from the PCM to that wire, so we don't have a shorted wire. And you could do that same check for pin number 2 on that connector as well. Right here, I'm testing pin number 3, which is our constant battery supply, and I do have the same voltage there that I had at the battery, telling us those wires are in good shape going to and from the PCM and to the battery. Now keep in mind that this is a good test to do for pin number 3 as far as the constant battery supply, but it's not a very accurate test for pins 1 and 2 that are going to the PCM, but it does tell us something, and with a regular multimeter, that's about all we can do anyways. So right here, I've actually already changed the alternator, but I'm doing these same checks with the engine running just to show you. So I've got my red lead with a needle on it and going into pin number 3, which is the constant battery supply, and I'm starting the engine. It is a good idea to do these checks with the engine running because under load, it might drop that signal. So keep in mind, this is a new alternator, and that's why we were getting that 13.8 volts after we started it. So I shut it off and I went ahead and put it in pin number 2 location. And we're going to do the same thing. I'm going to fire it up and see what I'm getting out of that. Now this is our command signal going from the PCM to the alternator, telling it what to do, and I am getting some type of a reference voltage on that. So now I'm going to go ahead and remove it out of pin number 2 and put it in pin number 1 and go through that same process. And you'll notice we are getting some type of a reference voltage out of that wire as well, and that's about the best we can do with a multimeter. Again, this is not the most accurate check, but with limited tools as far as not having a picoscope, this is about the best you can do. If any of those wires read like nothing or 0, then you would start wanting to look for a broken or cut wire, basically. So right here, after doing some more research and reading that if you unplug the pigtail, it does give you a fixed voltage of like 13.5 volts. I actually wanted to verify that. So this is a good alternator. This is after I already changed it. But you can see that we had 14.09 volts. I unplugged the pigtail off of the alternator and we're still getting 13.5 volts. And right here, I'm plugging it back in and you'll see it jump back up to that 14.09 volts, telling us that that default is working correctly. So now that we've gone through all those preliminary checks and tested everything as far as the wiring goes to the best of our ability with a regular multimeter, I did end up condemning the alternator. So right here, I'm just disconnecting the ground off of the battery. I also did put a little trickle charger on that battery to charge it up while I was replacing the alternator. I disconnected the 3-wire pigtail off of the alternator by depressing the plastic tab on that pigtail. So on most vehicles with serpentine, there is going to be a belt schematic on a sticker under the hood. If it is no longer there, I highly recommend taking a picture before removing the belt. Now, since I am just removing the alternator, I did not take the belt all the way off. I just took it off the alternator and set it right underneath it. In order to remove the belt, you will need a 3/8 ratchet, and there is a square hole in the belt tensioner that you put that ratchet in. and pull that tensioner over towards the driver's side of the engine to overcome the spring and take the belt off the alternator. Then using a 10mm socket, I removed the 4 bolts on the bracket that holds the top of the alternator. Then I removed the main charge cable going to the alternator using a 13mm socket, and went ahead and pulled that bracketry off to the side. Then using a 13mm socket, I loosened the 2 bolts at the bottom of the alternator. You do not have to remove these bolts, just loosen them up so you can pull the alternator up and out. I ended up getting my alternator from Napa, but they are available on Amazon as well. Before going to install any new part, I like to put it next to the old part and make sure everything is the same. The grooves on the pulley, the pigtail harness connection is the same and in the same location, as well as the mounting holes, making sure those are all the same. Because if something's not the same and you need to return it, it's a lot easier to do if they haven't seen you've tried to install it. So right here, I'm just setting the alternator on the 2 lower bolts that hold it in place, and then I took that top mounting bracket and got all 4 of the bolts started on that. I also put the main charge cable from the alternator to the battery back on and put the nut and snugged that down using that 13mm socket. Put the rubber boot back over the top of that. Then I tightened down the 2 lower mounting bolts first to align that alternator before tightening down the 4 bolts that hold the upper bracket in place. Then grabbed that 3/8 ratchet and put it in the belt tensioner so I could pull it back so I could put that belt back over the top of the alternator. Went ahead and cleaned that negative battery cable end since I had it off. Then I tightened that down using a 5/16 socket, or an 8mm for that matter. I removed the battery charger once it was up to a full charge and started the vehicle up. I went ahead and put my voltmeter back on the battery so I could see what it was doing. I was reading 12.38 volts before starting the vehicle. Once the vehicle started, I am up to 13.6 volts, telling me that the alternator is charging the battery and that we did rectify the problem. All that was left to do after that was put that decorative cover bullcrap back on. It slides into 2 tabs on the front, and then using that 1/4" ratchet with the extension, go ahead and tighten that rear bolt down. Hopefully you guys enjoyed this video and it gave you some good information. If so, make sure you hit that like button and subscribe to my channel if you haven't already. I'd really appreciate it. The whole concept of my channel is to give you guys the most information in the least amount of time as possible so I don't waste your time. And I hope to see you next time. Have a good one. Later.